Okay, let's go. So hello and welcome to this webinar, Dive into the Copernicus Marine Service. The second day out of 3 online sessions of the Copernicus Marine Service event, Marine Data for America. I'm F.Messal from Mercator Ocean. I'm Training and Education Manager. And let me introduce you P.Agostini, Project and Communication Manager at the Euro-Mediterranean Center on Climate Change. Hi, Paola.
Hello. Hello, everybody. Hello.
So Paola will be your moderator for this session. So I'll let the floor to Paola.
Thank you. Thank you, Fabrice. So welcome also from my side. Welcome to everybody. Good morning, good afternoon, good evening, depending where you are following us. And so this will be just a short introduction to what we are going to see today. You will see there will be presentations, very interesting about the products you may find on the Copernicus Marine Service, and also some demonstrations. And there will be time for questions and answers. Next slide.
Yes.
Okay, we already presented ourselves. So as Fabrice quickly mentioned, we are on a second day of 3 days workshop training dedicated to the America for the Copernicus Marine Service. Last week, you had the opportunity to participate to the webinar where you had a general introduction to the Copernicus Marine Service, and also you saw some examples of downstream applications of the data available for free from the website. While today and tomorrow you are going to see more details about the products, the data that are available in the Copernicus Marine Service for the global ocean, and so also for the areas where you live and work. Next slide. So today and tomorrow, in the 2 hours of today and tomorrow at the same time, so the 4 UTC today and tomorrow, we are going to have 2 parts of the days. The first part will be dedicated to presentations by experts in the different products available in the Copernicus Marine Service, from the in situ to the satellite to the modeling products. And together with this presentation, after this presentation, in both days, there will be a session dedicated more to practical experience with this and how to visualize in the QGIS with the examples of the Jupyter notebooks, with the ACRI-ST examples. Next slide. For today, the first 4 lectures that will introduce you to the first group of Copernicus Marine Service products are A.Mangin, Scientific Director of ACRI-ST, S.Good from the UK Met Office, and M.Drevillon and Perruche from Mercator Ocean, the first evaluator of analysis and forecasting system, and the second oceanographer and marine biogeochemistry modeler. After this first group of presentation, we will have the time for having question and answers. So remind that you have the possibility to put your questions in the chat, and then we will select some of them, depending on how many they are, for being replied live by the speakers. Otherwise, they will be replied anyway following the webinar. Okay. In the second part of today, we will have instead a couple of presentation, a live demonstration from Xavier Cedillo Valcarce from Mercator, and from E.Sahuc from Noveltis, and they will give you more information about the Panoply demonstration, the QGIS demonstration, and Fabrice will close the session with some other information. Okay. As I just said before, if you want to pose any questions to the speakers while they are speaking or just after, please use the chat in your training environment. We will select the questions and then we will pose it to the lectures, to the different lectures. If the answers cannot be answered today, then we will just follow the questions answers in the other after the workshop. Okay. Since the lectures may also reply to your questions directly in the chat. Yeah, that's next slide. Then I leave the floor to Fabrice.
Okay, just to say a few words about all the training material prepared by the experts. So you will have some hands-on exercises at your disposal on a dedicated platform on a specific Jupyter lab. So the experts and the developers have prepared a lot of Jupyter notebooks exclusively for you and dedicated on Central and South America. For each Jupyter notebooks, you will have a tutorial video recorded by the experts to explain you each steps of the practical material. And you will find also different other training videos available on GIS or made by the service desk to give you more detail on how to use the data, how to download the data, etc. So you should have received, or you will receive the user manual, the participant manual with all the links. Just a reminder that the Copernicus, the online solution we put at your disposal, the Copernicus Marine Service Jupyter Lab, is strictly reserved for you. So you need to register and to ask access to this Jupyter Hub by clicking on the link here, or you can copy this link, and you have just a very simple form to submit. It's just for us to be sure that you have been registered to the workshop and you can access to the Jupyter Lab. Okay, so just be aware that you need to be registered to the Copernicus Marine Service. This is one condition, because you will deal with different data, and you during the hands-on exercise you will have to download some data. So you need your account on the Copernicus Marine Service, and you need to submit this simple form to be sure that you are a participant of this workshop. Okay, and next, last information, you have this Padlet. So this is a platform, and we try to gather all the available resources for you. So you will find links to different products presentation, or the e-learning material from the Copernicus Marine Service website, the user manual, and the different use cases you already seen during the first week during the webinar. So the link is here. We can share this link again in the chat later during the webinar. So I'll let you continue with Paola. I wish you a pleasant workshop.
Thank you, Fabrice. Then now we start with our journey through the products of the Copernicus Marine Service that may be useful for you in your work and studies. The first presentation is from Antoine A.Mangin from ACRI, and he is going to present you the products related to the ocean color. So Antoine, the floor is yours.
Okay, thank you. Okay, so you Normally you should see my screen. Is it okay?
Yeah.
Okay.
Yes.
So good morning, good afternoon, everybody. So nice to be with you today. This first presentation will be about the products in the Copernicus Marine Service, which is related to Ocean Color. And Ocean Color is a nice name for a nice set of products. So when we talk about Ocean Color, of course, everybody is thinking that it is blue. Okay, but sometimes it's not so blue. So compared to the blue, we can have some green that will give you some information about the chlorophyll content of the water, so the marine biology. You might have some brown or red stuff that are related to the marine, suspended matter, in fact, particulate suspended matter. Also some yellow substance that are synonym of organic colored matter. And also at the end, you might have some information about the coloration due to specific phytoplankton and microalgae, so that are called algal blooms that are very prejudicial for the aquaculture, for instance. So starting from these colors, we can define and can derive, and we do derive information about the content in chlorophyll, sediment, organic matter, and algal bloom in the water. So just briefly, I don't know the background of each of you, of course. So briefly, we start with this satellite here, who is getting all the light that is backscattered from the ocean. And then we have to correct from well, some effect of clouds, etc. But we get the signal of the sea on board the satellite. And then after some arithmetics, we get what is coming out from the sea under the form of a marine normalized water living reflectance. So it's the ratio of the light which has been backscattered by the sea. And from this, it will give the coloration and then, as I said, some products. So here in pink, we have the optical products. So we have access to the absorption of organic matter or the scattering, the backscattering of the particles or the sediment. So the KD, which is a diffuse attenuation coefficient, which is a kind of equivalence to the transparency, and the Secchi disk depth, which is measurements of indeed of the transparency of the water. And then after this, we can derive other parameters directly linked to biology. So the chlorophyll content, the phytoplankton functional types or size distribution, and the primary production. So we'll show you some of these nice products. So remember that in pink, it's optical products, and in green, it is marine biology product. So first, let's start with a very famous marine biology product obtained from Ocean Color, which is the concentration of chlorophyll. So you have daily, monthly, yearly concentration of chlorophyll. Here, I just wanted to highlight for the South America, the hotspot, let's say, for marine biology. So of course, this polling area, very productive polling area. Here near Chiloé, there is an aquaculture fields, very, very large aquaculture fields, probably number 2, if not number 1 in the world. Here you have the Amazon discharge with a lot of turbidity and sediment problem. Here in the Caribbean, also some biological, very active areas, as well as in Argentina here. So you see here the hotspots of the marine biology. So already with the chlorophyll data. So here in the northeast, as I said, and here the upwelling on that western area, sorry. What is important here is to mention that for each product, for instance, the chlorophyll, we provide also in the Marine Corps service, we provide an error estimation. So you might know this this tool, this viewer tool, which is very fine. I hope you will have a demo of that. But please consider that for each product in the Marine Corps service, there is an error estimate, which is very important to use in a proper way the products. Here is an estimate of the primary production. So again, you see the productive areas here. So it's maybe not the best example, this one, but there's a lot of examples. So here also, if we are going to the north, we have access to other polling there. But you have an estimate of the primary productivity of each areas during the year. Here, interesting is if we are going down to the south, you might know that we have very productive areas with a lot of different phytoplankton functional types, different types and different taxa. For instance, the diatoms, which are very present in the 50s, let's say 50s south. And here I put you an estimation of the mass concentration of diatoms here for one day here. But also you have to consider that we have also products for dinophytes, aptophytes, green algae, prokaryote, prochlorococcus, and also distribution of phytoplankton size distribution. So that's important for when you are doing some ecological studies and some fish farming and fishing estimates and primary production estimates. Here is another proxy, which is the optical. So optical is a Secchi disk depth. So this tool, the transparency, that is to say the transparency of the water at which you cannot see anymore this tool. So this is an equivalent. So here you see very clear waters and here very less clear water, let's say. Here you have also a proxy, as I said, of the transparency, which is the attenuation coefficient, which express the penetration of light and so the warming of the upper layers of the ocean. So in summary, at European scale, all the ocean color products are available at 1 kilometer resolution for daily, monthly, and annual timestamp. And at global scale, which is probably more interesting for you because you're probably not working in the European waters, the same products are available, but at 4 kilometer resolution. But there is a new coastal chlorophyll product available at 300 meters based on Sentinel, so the Copernicus offer the Sentinel missions, again with daily, monthly, annual timestamp. We use all the data from back to the 97, so CWIF, MERIS, all the long list of sensors. And so we can derive, we have, and we offer to you the consistent time series since back to 97. There is an uncertainty estimate, again, which is quite important. And important as well to mention, all these products are documented in a very professional way and very consistent way. So with quality assessment and online product user manual. If you go to the catalog, to the large catalog of Copernicus Marine Service, you have to go to Global Ocean and then to, if you want some biological products, so the green one, you go to plankton or primary production. And if you want to have to look to optical, then you go to reflectance, transparency, and turbidity. So everything is available on the catalog. I have prepared a tutorial as announced by Fabrice, two examples, in fact. One is the marine productivity near Chiloé in the south of Chile, which is a very productive area for aquaculture. As I said, probably spot number 2 in the world. And this is the outflow of the Amazon River with turbid problematic, I would say. Just to illustrate this, in Chiloé, so here you have all the production areas, for instance, here in Castro, eastern part of Chiloé. And here there are a number of algal bloom, and it's very sensitive area. And you see that this is the product at 4 kilometers. And now you have this product at 300 meters, which is available everywhere. And you see that you have a much, much better definition of the blooms and the potential for blooms, for instance, here in Puerto Montt. This is an illustration, and the last one is about the sedimentary processes, as I told you, in the French Guiana coastline, so north of the Amazon estuary, where you see oscillation with the satellite data. You see oscillation of turbidity, which impact the bathymetry on these areas. So there's two examples are illustrated in the tutorial. So, okay, so ACRI, the company for which I'm working, is in charge of a part of the ocean color production at global scale. And I thank you for the attention.
Thank you, Antoine. Thank you for your interesting presentation. I remind, actually, I encourage all the participants to put the questions in the chat. And I remind that we will first have the full presentation on the products, and then we will address the questions together. So we pass now to the second presentation, this time by S.Good from the UK Met Office, and it will introduce you to the sea surface temperature products. Simon, the floor is yours.
Thank you. So I'm going to be talking about the satellite-based sea surface temperature products provided by the Copernicus Marine Service. So in the presentation, I'm just going to briefly say what I mean by sea surface temperature, or SST, tell you about the different types of SST and products that you might encounter, and then go into detail about the products provided by the Copernicus Marine Service for the global ocean. So what is sea surface temperature? When we say sea surface temperature, it can mean a few different things. So the diagram on the right here is something provided by the Group for High Resolution Sea Surface Temperature, and it defines various types of sea surface temperature. So at the bottom, at about 10-meter depth, is the blue star, which defines what we call the foundation sea surface temperature, which is the temperature for which the diurnal cycle grows during the day. And above that, then there's various different other types of sea surface temperature which would feature diurnal changes over the day. So the green stars what we call SST depth, which we normally would say a particular depth to go along with it. And then right near the surface, it's about 10 microns and a millimeter are the red and the yellow stars, which refer to the skin and the subskin sea surface temperature. That's the temperature that the satellite instruments that we use tend to descend. So depending on what you're interested in, the type of sea surface temperature you're interested in, you might encounter different levels of diurnal signal in your data. So I mentioned before satellite data, which is the main focus of the products I'm talking about today, but of course there's also in situ instruments in the ocean that we get data from as well, so like things like drifting buoys, and they measure at different depths. The satellite sea surface temperatures, there's different types of instruments that are used, infrared or microwave, and they may be on different orbits, so polar orbiting or geostationary platforms, which either allow us to see the whole of the ocean, or say once a day or something like that, or in the case of geostationary, many times during the day. So when we create the products, we're dealing with data that can represent different depths, and there may be even be biases relative to each other, which we try to sort out before making our products. And the diagrams I'm showing here are something else you might encounter. So these are satellite data levels. This indicates the amount of processing that are applied to the data. So on the top left, what we call level 2, which is when the sea surface temperatures are still on the satellite projection. So if it's a polar orbiting instrument, then you just get a really narrow, thin strip of data, which is how the satellites viewed the Earth. And then that could be reprojected onto a regular grid, which is shown on the top right, which is what we call level 3 uncollated. So we have a single orbit of data on the one plot. And then going even further, we can go to the bottom left, which are level 3 collated or super collated data, where we've either combined together multiple orbits from the same instrument, or either from, or in the super collated case, from many different instruments. But you can see there that there are still gaps in the data which may occur through things like cloud, because the infrared instruments won't be able to see the ocean through cloud. So there's a further level of processing after that, which is level 4, where we've provided infilling to make a spatially complete field. And the Copernicus Marine Service data that we provide are all at level 3C or above. There's the bottom 2 of those examples. Now, if you want to find the global satellite sea surface temperature products in the catalogue, you can go to the Copernicus Marine Service webpage at the link on the bottom left. And the easiest way to find them is to type the letters that are in the red oval into the search, and then that brings up these 6 different products, which I'm going to go through in detail in a moment. But I just wanted to mention before going on to that we use a standard data format, which is defined by the Group for High Resolution Sea Surface Temperature. It's a net CDF. This means that it's easy to read into most software, and it's easy to switch between them as well, because they're all using a standardized format. And as well as these global products, if you're interested, there are European regional products available too. So the first 2 products that I wanted to highlight are here. So the top one I'm showing is a level 3S product. So as I was just explaining, this means that there's no infilling done on the data to fill in for things like clouds. So if you don't want the infilling, this is the correct product for you. This one is at 10th of a degree grid resolution, and it represents the foundation sea surface temperature. At the bottom of these 2 products is an ensemble of level 4 data sets. So we've taken level 4 global data produced around the world and combined them into a single product. This is a 1/4 of a degree grid resolution. So if you're interested in the differences in what different data producers produce for various regions of the globe, then this is a good product for you. But in particular, there are sea surface temperature gradients provided in the data file. So if you're interested in gradients, then this could be really useful. So the next 2 products I'm highlighting are foundation sea surface temperature products. These are at grid resolution of 1/20th of a degree. So as they're level 4, and as you can see, the plots show there, these are spatially complete. And the reason there's 2 different products is one is a near real time data set. So it's produced every day for the previous day. So it's right up to date. And there's also a reprocessed historical data set, which goes from late 1981 to near to the present. So if you want a consistently processed data set spanning multiple decades, then that's a good one for you. We also have a diurnal data set. So the previous one, because it was foundation sea surface temperature, was just daily, but this one has hourly values through the day. This is a 1/4 of a degree resolution. And the plot here is showing the difference between the skin sea surface temperature, which is provided in the files, and the foundation sea surface temperature. So you can see how the diurnal cycle progresses through the day. Finally, there is a product that's designed specifically for climate research use. This was produced by the European Space Agency Climate Change Initiative and the Copernicus Climate Change Service, but it's available through the Copernicus Marine Service too. So it represents daily average SST at 20 centimetre depth, which is chosen to be consistent with the depth of some of the in situ instruments that are used further back in time before the satellite era. Again, it's at 1/20th degree grid resolution. As I say, this is designed for climate research. Based on those, we've produced ocean monitoring indicators. These are available from the Copernicus Marine Service website at the link shown there. And the plot at the bottom right is an example of one of the ocean monitoring indicators showing the trends globally over since 1993. As well as that, there's also annual anomalies provided and a time series of global average sea surface temperature. So in conclusion, the Copernicus Marine Service provides 6 global satellite-based sea surface temperature products, but also there's European region products available if that is of interest. We're using a common NetCDF format specification for all of these, so it's easy to try switching between them. That's very easy to do, and because they follow standards, it should be easy to read in most software. And we've got products covering hopefully most use cases, so different data levels, different SST definitions, and both near real time and consistently reprocessed. And we have ocean monitoring indicators available also. So thank you.
Thank you, Simon, for your presentation. And so I know that some questions are posed in the chat. I just encourage the participants to follow with the questions for all the presentations. And now we pass to a different group of products, because up to now we saw products derived by satellite, and we are now moving to a couple of examples of products that are from the modeling activities. And the first relates to the physical products. And so M.Drevillon from Mercator Ocean will present you this category of products. Marie, the floor is yours.
Thank you, Paola. Good morning or good afternoon, everyone. I'm sharing my screen. Okay. Is it on? Yeah?
Yes, maybe just the presentation mode.
Should be on. Okay, it's okay.
Perfect.
Right. So I'm going to talk about the model products, the high resolution model products for the physics. So ocean temperature, salinity and currents, and sea ice. So these are produced by a global monitoring and forecasting center within the Copernicus Marine Service. So we are producing several products for the physics, for the biogeochemistry, and also for the waves, which are going to be presented later. And I'm going to focus on these two physical model products. There is one for analysis and forecast in near real time. And there is a reanalysis for the past period. So these model products are prepared by a rather large team of people within Mercator Ocean International, which is located in France. So we are working with French partners, but also with European partners to do this work. And if you are looking for these model products on the CMM's catalog, you will have to search for the 124. So it's the Global Analysis Forecast Physics. It is at a 1/12 of a degree horizontal resolution, and the parameters that you can get are temperature and salinity, sea surface height, 3D currents, mixed layer depth, sea ice concentration, sea ice thickness, and also sea ice velocities. It is available from 2018 to present. And of course, you have several frequencies: hourly means, daily means, monthly means, 6 hourly instantaneous fields. These products are based on a model assimilating observations. So we assimilate satellite sea surface temperatures, sea level anomalies, in situ temperature and salinity profiles, and sea ice concentration satellite maps. The forcing which is used is the ECMWF operational high resolution analysis and forecasts. And we update the ocean analysis every week. So the data assimilation is performed each week on Wednesdays. And the forecast is updated each day, every day, using the latest forecasts from ECMWF. And as I said, consistent reanalysis is also available. It is forced by ERA and TRIM, which is an atmospheric reanalysis from ECMWF on the period 93 to 2019. So there's also a publication from Lelouch et al. In Ocean Science that you can read for more information, and there is also online documentation, of course. Now, what about the quality of these model products? So I'm going to focus on the currents here. These are surface currents comparisons with drifter observations. So we deduce velocity from the observed trajectory of a surface drifting buoy. And we bin the comparisons into 4x4 degree boxes for the year 2019. This is why you have a global coverage. And this you are looking at is vector correlation. And it is almost, well, it's yellowish to red everywhere, which means that the vector correlation is good on average over the globe. So we have a good agreement with the observations. So that's quite nice. And I can also show an example, which is also used in the Jupyter notebook that you will see tomorrow, I think. This is an example of validation in the western South Atlantic along the American coast. And this is the Malvinas current. You can see on this map going from south to north. And the model fields are compared with independent observations, temperature and salinity profiles, and an ADCP for comparison of the velocities. But here the velocities are compared. The ADCP gives the velocity at 300 meters depth on the left, and you can compare with the model velocity on the right. So you see there's a good agreement. And this is for 1 year from January to November. It is year 2015. And there are also in this paper from Artana et al., you will also find comparisons with temperature observations here within the dots. You can see the observations overimposed over the model estimation. This is along this section here, along the Malvinas current. So that's also a nice example of validation, but done by a user. Now you can also have access to recent quality indicators from the CMEMS website. There is a product quality dashboard that you can find in the user corner or in the access data part of the website. And on this platform, you will be able to visualize moorings, SST moorings, for instance. Here, this is time series in the Northern Pacific. The orange time series is the observation, which we can compare with the analysis in purple, and also 2 different forecast lead times at 12-hour and 60-hour. And you can see that there's a good agreement even at high frequency with the mooring, with the SST mooring. We also do statistical comparisons over rather large areas to provide the statistical behavior of the system. So this is an average difference between salinity observations and the model counterparts at different forecast lengths that we make in the North Pacific Ocean here. This is for salinity in the 0.5 meter layer, so near the surface. And you can see the evolution in time of the statistics over that rather large area. This is also available from the product quality dashboard. So the uncertainties are not very high, and the variations strongly depend on the uncertainties in the atmospheric forcing and river inputs. And here on the right, this is the same type of plot, but here it's an anomaly correlation. It's not a deviation from the observation, but a correlation with the observation. And it is also for the analysis in blue and several forecast lengths in purple and green. So the correlation here decreases with the forecast length. So as the error grows, the correlation decreases. And in that part of the world, so here we're in the tropical Pacific Ocean in the western part, and in that part, we know that there is a bias, and so the correlation is not so good. And all of these systematic biases and the strengths and the weaknesses of the model products, they are described in a quality information document, which is also available on the catalog. So you can know more. Now a few words about the reanalysis and the long-term trends in model products. So this top panel is a regional sea level trend that you can get from observations of sea level. So from the Sea Level Thematic Assembly Center of CMEMS, you can perform this computation of regional sea level trend. And in the lower panel, this is the sea level trend, which we obtain using GLORIS, which is a reanalysis from the global MFC. So you can see that there's a good agreement, even at the regional scale, between the two trends. And we are currently assessing this high resolution reanalysis to see if it's if we can get ocean monitoring indicators from this reanalysis. At the moment, the ocean monitoring indicators are using a lower resolution reanalysis. So we are planning to update this. And so all these model products are going to be improved in the near future. We are working on a climatology deduced from this reanalysis, which will be on the catalog very soon. We are also working on model upgrades and the improvement of SST assimilation to have better viability of the SST from day to day, and also the improvement of the atmospheric forcing. We're going to use higher resolution, higher frequency atmospheric forcing. So there's also an article submitted to Frontiers describing the reanalysis from the high resolution model products. So that's all for me. Thank you.
Thank you to you too, Marie. Thanks. And we pass now to Coralie Perruche from Mercator Ocean for the biogeochemical modeling. I remind you about the questions. After this presentation, we will see some of the questions you have posed in the chat and reply live to them. So now, please, Coralie, the floor is yours.
Hello, hello everyone. I share my screen. Do you see my screen?
Yes, perfect. Thank you.
Okay. So I'm Coralie Perruche from Mercator Ocean, and I'm going to talk about the global biogeochemical products. So that is to say the reanalysis and the analysis and forecast systems. So here are the colleagues who are involved in the developments of the biogeochemical systems. We work on the model development and implementation, both for the near real time and the multi-year systems. And we work also on data assimilation methodologies and on the whole validation process with many kinds of observation. So let me start with the biogeochemical model. So for global configurations, we use the PSCES model. It's a model of intermediate complexity with 2 phytoplankton generic species, 2 zooplankton species, 3 compartments of detritus. In phytoplankton, we distinguish the content in carbon, in chlorophyll and iron. And specifically for the nanophytoplankton, we distinguish the content of silicon or diatoms, sorry. And the ratios, the rate field ratios between carbon, nitrogen, and phosphorus in phytoplankton and zooplankton are kept are constant. So on these pictures, on this picture, you have all the processes that are modeled in PSCES. So for example, nutrient uptake, grazing, natural mortality, remineralization, sinking of particles, and so on. And on top of that, there are also external supply of nutrients from rivers, from dust deposition, iron from sediments, and from sea ice. So talking now about the global systems, we have 2 systems on the Marine Copernicus portal, the near real-time one on the left and the multi-year product on the right. Both systems have common modules for the sake of homogeneity. They are indeed operating the 3.6 version of the NEMO PSCES biogeochemical model on a global quarter-degree grid and are forced on an offline daily basis with the NEMO 3.1 physical model. But there are also a few differences between the 2 systems. The near real-time systems is forced with a higher resolution physical model, and there is a coarsening towards from 12 to quarter-degree grid. Then there is data assimilation in the physical model. There is also a relaxation of the biogeochemical model to some nutrient climatologies, allowing the BGC model to develop its own seasonal and interannual variability. In fact, this is done to mitigate the impact of physical data assimilation that has been shown to generate an upward flux of nutrients and thus an overproduction in the tropics. And at last, the biogeochemical model is also constrained by the assimilation of ocean color surface of observations that allows to calculate a correction of both chlorophyll and nitrates in the mixed layer. And for the multi-year system, it is forced by a non-assimilative physical system and has no biogeochemical data assimilation component yet. So in an effort of simplification, both systems provide daily and monthly fields of chlorophyll, phytoplankton biomass, nitrate, phosphate, silicates, iron, surface partial pressure of CO2, pH, primary production, and oxygen. And on top of that, the real-time system also provides 10 days of forecast. So some indications to get this product. You go to the Marine Copernicus catalog, you click on ocean products. Then you search products number 128 or 129. And at last, you click on more info, where you have a small description of the product features. And in the documentation tab, you have the quality information document that presents a thorough assessment of the product. So from now on, I will focus on the near real-time product by showing some plots of the validation procedure. So here, some basic validation of surface chlorophyll. We use here the global ocean color product of Copernicus to assess the climatological and large-scale chlorophyll distributions. So on top panels, you have the surface chlorophyll on the left for the model and on the right for ocean color observations. And we can see that the agreement between the model and the ocean color data is quite satisfying at large scale. And on bottom panels, you have the RMS difference and the log bias. And the RMS difference is quite satisfying in a very large area in and around the oligotrophic gyres. It increases in the more productive regions in mid and high latitudes, which are more turbulent and less efficiently observed by ocean color sensors. Here, I show the quality evolution of the system between the two last systems with a Taylor diagram. That kind of diagram allows us to synthesize basic statistics like correlation, RMSD, or standard deviation. And it's on a single plot. So in red, you have the old system, and in green, the new one. Here we consider 4 quantities. In squares, you have the log chlorophyll average in the 100-meter layer, the surface 100-meter layer. With the circles, you have the same for nitrates. You have triangles up and down that indicate respectively the oxygen at sea surface and the oxygen at 300-meter depth. And the yellow star is the reference data sets that the model should be as close as possible to. So this reference data set is the Biogeochemical Argo float database that is totally independent. And these statistics are computed at global scale over 3 years. So we see a clear improvement in quality between the 2 last versions. And at last, we also monitor the quality of the system along the trajectory of BGC Argo floats. Here you have 2 examples in the North Pacific subpolar gyre. On the top panels, you have nitrate from a float in the Gulf of Alaska. You see that the model captures well the seasonal cycle and the progressive change of regime. And on the bottom panel, you have again a float in a subpolar gyre, but here it's the concentration of oxygen, and you see that the model is able to reproduce the deepening of the oxycline along the float trajectory. So to conclude, these global biogeochemical systems have a wide range of applications. They are, for example, used to force higher trophic level models like the one of the Marine Copernicus web portal. Here it's micro-RIS. You have an illustration here on the right of the concentration of microneutron from this system. Our products are also used as boundary conditions for higher resolution regional models. They are used also to do global indicators, and they are also used for research studies, like to analyze the impact of marine heat waves on plankton ecosystems, or the impact of ENSO variability. So thank you for your attention, and I will be happy to answer your question.
Thank you, Coralie. Thank you. So now we have time for some of the questions that were posted in the chat. I would like to invite the four speakers to also open the camera so that we can see you while you answer. We have prepared the questions, so you can also check them in the screen. The first will be for Antoine. So I'm going to read it. You mentioned the error analysis of chlorophyll A at point of interest. Is it easily included when preview the data from the web? Could you tell us more about that? Thank you.
Yes, I can try. Okay, sorry, I cannot switch on my video because it has been switched off by somebody else. I don't know. Okay, so it works now. Thank you. Just to say, okay, it's very easy to have these estimates of the error using the MyOcean viewer tool, in fact, directly. Okay, you just have to click, you use this tool, so you have to go to MyOcean viewer. Maybe you already have a tutorial on that, I don't know, but it's a very powerful tool. And then you can display whatever product you want, either the map of the uncertainty as well, or to point and to ask for the uncertainty on this specific point. So, okay, so I hope it answered the question.
Thank you. Yes. So the next one is also for you. Am I correct to think that the 300 meters ocean color data is only available globally for 1 year through the CODA?
Okay, I don't know exactly what is CODA in very specifically, but what I have to say is that we have added the 300 meters resolution ACRI-A and ACRI-B products to the Copernicus Marine Service since 2 months, more or less. And it goes back to the 1st of January of this year. And it is processed every day now. You can go to the website and you will see that the data from yesterday is available worldwide. It is limited to a coastal area of 200 kilometers, which is already quite big, just to catch some coastal features. And it will be processed back in time, that is to say back to 2016, the launch of ACRI-A. In the next weeks, months. Okay, but at least we have already 6 months in the house, and it is processed every day.
Okay, thank you. The next question, still for you. So about the product, the size and type of phytoplankton, does the product have a biological model, and does it have a turbidity correction?
So in fact, it is not a biological model. It is just we detect the different type of phytoplankton, so the diatoms, for instance, and the green algae, because of the shape of the spectral signature. Okay, so thanks to the spectral signature, we can say, okay, there is this amount of diatoms and this amount of dinoflagellae, etc. So there is no explicitly biological model. And there is no specific turbidity correction because turbidity has another spectral signature, so it is not mixed with this classification of PFT. It's the same for the size.
Okay, thank you. Next question is for Simon. Can you give us some information on how you calculate the trends in the SST data, especially for regions that have a strong seasonal cycle?
Yes, well, we remove the seasonal component from each grid point to separate out the longer term trend, and we use a robust method to estimate the slope of the trend. So full details of this are available in the quality information documents. So if you go through the Copernicus Marine Service website to the ocean monitoring indicator, you should find that document, and it will give you all the details that you want to know.
Okay, thank you, Simon. I think this refers to Marie. Presentation, is the vertical velocity W available for this model?
No, it is not yet available as such in the catalog, but you can recompute it from U and V using a continuity equation. Or alternatively, you can contact Mercator Ocean for vertical velocities on the model grid. But if you want to stay consistent, you use the U and V and recompute the vertical velocities.
Okay, thank you. Are there other questions? Yes. How to access and download in situ chlorophyll A data from Bay of Bengal?
It's too easy. It's too easy. You go to the catalog. It's very, very easy. In fact, in a few clicks, you can have access to the data, and you can even view it before, either by using the catalog or by using, as I said, the My Ocean viewer tool, which is really very nice to use. So you can already see if you prefer to go to daily data or to monthly data for the coverage, if you want to go to level 3 or level 4, and then you can order this, and you can go to the tutorial I've prepared to see how to download in situ. Sorry, it's in situ chlorophyll A. Sorry, there is a mistake in my answer. Sorry. In situ, you have to go to attend tomorrow, I think, because there will be the session about in situ TAC, thematic assembly center, and if there are some in situ chlorophyll A for Bay of Bengal, you should find them there, probably, the most probably. Sorry.
Yeah. It's okay. Yeah. Next question. Is there any plans to run a 1/12 biological model?
It's not planned yet, but we have to run some tests for the time being, because it's very CPU consuming. So so we haven't done that yet.
Okay. That's Jan. I think there are other questions coming, so let's wait. Yeah, surprise. So how do you deal the mixotrophy in the biogeochemical models?
In fact, in the case model, for the time being, we don't have this parametrization. We don't represent the mixotrophy. Maybe in the next version of the model, it would we would need to increase the number of state variables. So
okay, thank you. Are there other questions? Yes, one is coming live. Yeah, how reliable is the Pisces? I'm not sure about the restitution of the Pisces. Okay, now because in Italian it would be Pisces. Anyway, Pisces, when we apply it to the, for example, St. Lawrence River in Quebec.
It's not easy to say. In fact, because we do global configuration, so I cannot answer easily. Maybe you can contact me directly, and I will study this.
Okay. Are we? No, there is another one. I guess coming. Maybe the last one. Yeah, in fact. Okay. Is the possible building optical products with 1 kilometer resolution for coastal regions of the South Atlantic Ocean? I'm not sure if this is for Antoine.
Yeah, I think it's for me. Of course, it's possible to build optical products with 1 kilometer resolution. it is not done today because of the size. Probably the question is about the 1 kilometer resolution, because it is done at European level, but not in the South Atlantic. But of course, this could be an improvement of the Copernicus Marine Service. So I don't know who asked this question, but please do some lobby toward Copernicus. And then each time there are 100 requests for the same product, at the end, okay, we provide it. It's a joke, but just to say that, okay, please send to Copernicus Marine Service your request for specific products, and normally it should be okay. And just a matter of production, which is quite large today. But at least today you have this optical product. No, not optical product. This is only chlorophyll. But okay, please send your request to Copernicus Marine Service.
Okay. Okay, thank you. I think we have answered almost all the questions. Thank you to all the speakers. Thank you for the time, and also thank you for the material you have produced. So I remind the participants that you will find not only the presentations of today, but also the notebooks for the exercises that will be also introduced tomorrow, and the videos of the same experts showing you how to work with the notebooks exercises in your material, in the training material. So you can still learn from these high-level experts that we have today. So thank you very much. We have the break right now, 10 minutes, and then we will reconvene again for the practical sessions of today. Thank you.
Okay, we are back now with Paola for this second part of the practical workshop. I would like just to mention one thing about the Padlet. We try to collect all the material we think interesting for you on this Padlet, and what you saw just before the break, it's just an overview, just few presentation about the products, but this is just an overview. If you want to have access to more detailed presentation, you can go to the Padlet and you will see the presentation on ocean color, sea level, SST observation, etc. And one more thing, if you go on the column introduction at the end, you have this link, where you come from. It's very cool to share your location. If you can share your location, for example, you have access to this map. I just pinned my location, so I'm in France, in the south of France, and I encourage you to go to the map and pin your location. Okay, and that's cool to see where you come from. Okay, Paola, I'll let you the floor.
Thank you, Fabrice. So we go now into some practical examples, and the first speaker and the first trainer for you to guide you through the Panoply tool is Xavier. And,
yes, yeah. Hello everyone.
Thank you. The floor is yours.
Okay. So hello everyone and welcome to this well, my name is Javier and welcome to this presentation, Panoply presentation. I'll share my screen so you can see how we work through it. So first of all, what is Panoply? Panoply is free software developed by NASA, which allows you to plot geo-reference arrays from several datasets such as NetCDF, HDF, and Greek data. Why is this interesting? Because Copernicus Marine Service delivers all his products and all the data in NetCDF's format. So you can use this tool or application to create simple plots, and it's really user-friendly. So if you have some trouble with scripts or coding, this is a really easy tool you can use to plot some information. So first, this is the NASA webpage where you can download Panoply. You just need to click here, and you will have, like you see, different versions depending on the operating system you have. And the only prerequisite you need is just having Java 9 or a later version. So that's it for the start. Then I'm going to dive in what's Panoply. This is Panoply. This is what you get when you start the tool. And well, first, what we are going to do is open a file. You just need to click here on File and open, and click on Open. Like a normal browser. I'm gonna select a pre-downloaded file I already downloaded for this presentation. So here you have two sides of the screen. On the left side, you have all the variables inside the file. The first three are just reference variables to reference the data. And the four underneath are the variables I downloaded through the Copernicus Marine Service. And I'm going to use them to give you some examples. And on the right side, what you have is some extra information regarding those variables. For example, the units axis, for example, max and mean value, all the extra data you need to understand the variable. So now let's dive into some of the features Panoply offers. I'm going to show you 3 of them, and then I'm going to show you how to export the data. So first thing we're going to do is to create a 2D plot. And to do so, you just need to select one of the variables you want to plot. I'm going to select this one, wave height, and you can plot the data just with double click or just clicking on create plot. In this case, I will use create plot. These are the kinds of plots you can create. In this case, I'm just going to use the first one. And here's the data shown on the global map. As you can see, there's only data on Central America because I focus my example on Central America. The rest is gray because there's no data on that part of the world. So I don't forget here, this is the data plotted on the graphical interface. And here you have the raw data. The data is like a matrix where you have all the data, all the variable data for each of the grid points on the map. For all the latitudes, all the longitudes on the array. And here on the right side, you have some zonal averages that may be interesting for you. And as a tip, sometimes this data is a bit difficult to read, so you can format data and change how it's expressed. In this case, for example, with more decimals, or maybe you want to use the exponential one, just the one you prefer. Coming back to the graphical interface, I'm going to show you the use of some of these tabs. I'm going to start with the scale one. First thing here is the range of the data. As you see, it's between 0 and 3.22. This is like the minimum and maximum right now on this time step, but you can change it. You can put here, for example, 2, and you will see it changes. I'm just gonna feed it to data. You can change the units also to scalar or logarithm and change the factor if you want. Again, formatting, you can change the formatting of the label. Here on the bottom side, it will change, for example, here. And you can also change the captation. For example, in this case, clicking here on custom, you will see it changes. And you can write whatever you want. In this case, I'll just leave it as default. And finally, on this tab, you can also change the color of the color bar if you don't like the one that's used right now. I'm just gonna again leave it as the default one. Next, I'm going to show you the map tab. Here, before anything, I'm gonna show you how to zoom in on the data because this is a small area and it's sometimes difficult to see what we're going to do. So for that, you just need to click on plot. And in this case, click on plot in. As you can see, there's also a command you can use to do it through the keyboard. I'm gonna zoom one time and I'm gonna zoom again a couple more times. As you can see, the data is not centered, but there's an option here where you can center the data. In this case, I know more or less the center point because I already calculated before, and I'm gonna center the data, as you can see. Okay, let me zoom in one more time. There you have it. So this is the part of the world that I'm interested right now, Central America. And because it's, I'm gonna show you the impact of one hurricane, the impact of a hurricane on the wave height on this part of the world. Next, the overlay tab is where you can add some information, extra information on the world map. Right now we have the Earth plotted on the graphical interface, but we can also plot more things. In this case, for example, we can plot the limits of the countries. Like you see, Mexico and United States and all of them in Central America. Or, for example, you can also add lakes or rivers, like Rio Grande there, and some of them in South America. In my case, I'll just leave it blank right now. Then we have the contour tab, where you can add some contours. Sorry. So you can see where the data has a specific value, like some geodesics. And in this case, if you want to have more scales, ticks, you can just select here major and minor, and you'll have more. And for extra information, you can also click on label, and you will have extra information here. For example, 194, 066, and an extra information on the height of the wave 1.3 here. In my case, I'm just going to leave it simple, so it's easy for you to see everything. Last but not least, we have this tab, label, where you can change the plot name and the plot title. For example, here I can just remove, for example, the variable, and here, for example, I can add just Central America, and you will have extra information on your plot if you want to use it for some presentation. And I don't want to forget it, but the most important one is array. Right now you have the data on one time step on this region of the world, but just one time step. How do you change the time step? Using this tab and utilizing this small box. How can you change it? First thing you can do is just select the drop-down menu here and select just one of the dates available. In my case, I'm using wave data, global wave data, and the data is available, as you see, it's 3 hours. So that's the time step, 3 hours. In my case, for example, you can choose this one, see, and the data changed. You can also select manually here, writing, for example, 5 or 8, and the data will change. Sorry, that's out of the range, 8. And the last one you can use is just drop down, opening the drop down menu and using the arrows on the keyboard to move the time step one time at one time each. And you will see how in this case, this hurricane I was talking to you about is increasing and is approaching the coast of Nicaragua and the impact on the wave height. Don't forget that each time you change the time step, the maximum and minimum values on that time step change. So you can adapt the values or the range of value for the new data. In this case, if I click on fit data, you will see that it changes from 3 something to 423. And if I change the time again, for example, on a later date, where the wave height is higher, and I feed it to the data, again, you'll see it change. It will change. So don't forget to change it if you want to show a better resolution. That's it for the first feature. The second feature I want to show you is how to combine plots. You can have one screen and have 2 plots at the same time. For this example, I'm going to add to the previous plot the direction of the waves. We have the height of the waves, and I want to add the direction of the waves. How you do it? You just select the variable and click on Combine Plot. You will have a drop-down menu where you have all the available windows you've opened. In this case, I just opened the previous one, so I don't have any other option to select. And then you click on Combine. And on my previous plot, you will have the two variables at the same time. Right now, you can't really see anything because what has happened? What has happened is that the tool has plotted the variables as array 1, that's a wave height, minus the wave direction. But that's not what we want. What we want is vector magnitude. This way, we will have on the background the wave height, and on top of it, we will have the direction of the waves. As you can see, this window is pretty similar to the previous one. We have the first array here with the raw data. This is the previous data, wave height. And now we have a second array. This is the new data we've added. That's direction of the wave. Again, you can check it and again, format it as much as you want. Coming back to the graphical interface, most of the tabs are the same. You can do more or less the same things as I showed before, but there are two things specific for this kind of feature. The first one is this one. What does this button do? This button, what it does is links both time steps of both data sets. If you don't click it, you can just show one time step different from the other one. For example, this is 13 and this is 1. But usually what you want is having the two of them at the same time. So if you change one, both values will change. And you will have the actual value for the actual time step for both of the data sets. And the second thing that's interesting in this case is the vector tab. This tab wasn't really available previously, and now that you have a direction variable, we can use it. Here you can select the style of the vectors, the color, maybe you want to change it. This one you can really see it, but let's keep it black. And the reference value. If you change this number, for example, if I put 4, you will see it reduces it adjusts, or reduces in this case, but adjusts the arrows and taking into account this reference value. And you can also put more arrows if you lower the spacing between the arrows. And right now it's 120. If I write 80, you see you will have a better resolution on the direction of the waves. In this case, if I write 70, you have extra arrows with better resolution. So, and that's it for the second feature. And the third feature I want to show you and I want to talk about is that Panoply can also plot 1D information. How do you do so? It's more or less similar to the previous things we've done. In this case, again, I'm going to select wave height, and then I'm going to select or click on create plot. But this time, instead of selecting the first type of plot, I'm going to select the last one. And instead of latitude for the horizontal axis, I'm going to select time. So we have the value of the wave height along the whole time series. This is the time from 14th of November until 19th of November 2020. That's the range of time I selected for this exercise. This is again tab close to the previous one, but with less options. Again, here at the top of it, you have the raw data. And again, you can format it as much as you want. What's interesting on this kind of plot is that you can have the value of wave height, in this case, of this variable for each of the grid points on the data set. Right now, we have the value, oh, sorry, this is automatically click the average. We have the value on the grid point 0 degrees north and 110 degrees west. You can move them and select different grid points on the data set. I'm gonna select a previously one that I know is interesting. example, this is 40 degrees north, and 361 that I know is 80 degrees west. So this is the grid point on this this position for the whole time range. But as you can see, you can't really see all the data. Why is that? Because we have to adjust the range. It was previously adjusted for the previous range of data, but I now want it for this range of data. And how do you do it? You can manually do it, or just click on reset, and you will have the minimum value, and maximum value. And you can see this nice graph where you can see how the hurricane, this hurricane impacts with the wave height until the maximum, that is around 16th of November, early 16th of November, and then it decreases when it passes this grid point, this point on the surface of the Earth. And all of the things that you could do previously, you can do it here. You can adjust the time, you can adjust the range, and something I think it's useful for this kind of graphs. Sometimes so much white on the background is sometimes a bit difficult to look at. You can change the background here on the label tab. You can change it and put black on the background. So sometimes it's easier, it's not so aggressive on the eyes. Just a quick or a small tip. So that's it for plotting. 3 features I wanted to show you. Now, just some information on how to download this data or download these plots. In this case, for example, if you want to download this image, you can do it just clicking on File on the window, clicking on File and saving, Save As or Save. You will have several options of types of file you can save this image, and you can do the same for the other one, for the other plot, the 1D plot. Just File, Save As, and again you have several types of files you can save this information into. Another thing interesting, for example, in this case, it's a variable that it changes over time. So maybe you want some small animation, some small video. You can also do it. How you do it? Clicking on File and on Export Animation. Here you will have some small things you can tweak. FPS, if you want to change the formatting of the video, etc. And you will get, I did one previously, so I can show you, you can get something close to this. You see, you have the wave height, and you see how it changes over time due to this hurricane that passes through Central America and into Nicaragua. And the last thing you can do that's really interesting for most of our users is to change or to export this data into another type of data, not just the plots. How you do so? In the main menu of the Panoply application, click on File and click on Export Data, and you can export it as CDL, CSV, or as a tabular data. The one that's most useful, or our users want to use the most, is to change it to CSV. Why so? Because if you change to CSV, you can open it on Excel and use this application to play with the data and do graphs and everything you want to do with it. And well, that's it for the Panoply presentation. Just a quick reminder, if you have any questions, you can ask Service Desk. We are always happy to answer all your questions. And maybe you can also check here on the NASA webpage, you can also check the documentation. Here you have some links that link you to some useful information, and maybe you can answer some of your questions. And well, that's it for the Panoply presentation. Thank you for everything.
Thank you, Xavier. Actually, we have some questions for you. I will go quite quickly. Okay. The first one, I think you replied during the presentation, but just to check, is that in Panoply, can you overlay one or more images, and you show the examples after? So I think it's yes, the answer.
Okay.
The other question is it possible to calculate and display an average of serial times of any variable, or just 1 day?
Okay, sorry. Can you repeat it, or maybe I can repeat the question?
Yeah.
Sorry.
you can also check it on the chat. And is it possible to calculate and display an average of serial time, I guess it's time series, of any variable or just one day?
In this case, I'm not sure. Maybe what you could do is it's supposed to calculate and display average of serial time or any variable just one day. I will need to check it. I'm not right now. I'm not sure. I need to check it. I'll try to look into it and answer the user a little bit later.
Okay, so we'll keep the answer for later. And there is another one. Can we export to vector graphics?
I think what the user is asking is what I did with the combined plots, with the vectors, with the directions. I'm not sure if it's what he's looking for.
Okay, so maybe you can ask more details. And the last one is, well, actually, I don't know if you can reply because it says, I have had problems installing Panoply in Linux environment. Do you have a tutorial for this?
I think we have it. I mean, we were going to create a small tutorial. I think we had to create Panoply. I'm not sure if it's already available on the webpage. I need to check. But I mean, if it's not already there, you can ask Service Desk and they will give you the information how to do it. No problem.
Okay. Okay. Thank you again for this interesting presentation for the demo. Thank you. So now we pass to the second part. So we will, Etienne has recorded the video, so we will first show a video and then Muriel will answer the live questions, your questions. So now we start with the video from Etienne. It's about the QGIS demonstration.
Hello everybody and welcome to this CMM's presentation and demonstration. I'm E.Sahuc from Noveltis and today I'm going to introduce you to a new QGIS plugin developed by Noveltis for the Copernicus Marine service and which enables an easy NetCDF files manipulation. NetCDF is a command file format used for meteo and oceanic data which handle several variables. All data available for free on the Copernicus Marine Service are distributed at the NetCDF format. In this first part, I will show you how to download and install the NetCDF plugin and how to use it basically. The zip file used to install the plugin is available following the link in the description of this video, and the user manual is also available. Once you have opened your QGIS software, you can go to plugin, manage and install plugin here, and you can go to install from zip to install plugin from the zip file downloaded on the CMM's website. You can browse on your directories and select the NetCDF to QGIS.zip and click on open. Here you can click on install plugin. The plugin is already installed on my QGIS, and close this window. I need to inform you that you have to install QGIS with the OSGeo4Wind method as described in the user manual to avoid any problems of Python environment in QGIS with this plugin. Once it is done, you can see that the icon of the Copernicus Marine Service is here, and you can click on it to open the plugin. Here you have two separate panels. On the left side you have the NetCDF and the QGIS layer panel, and on the right side you have a panel corresponding to variables, metadata of the NetCDF files, and some options. First of all, we are going to set this path on the option panel. first of all, you can add an input default directory. So to load your CMMS or NetCDF data, you can select the directory containing your data and click on select. And on the save default directory, you can select the default directory to save the new layer you are going to create with this plugin. So you can select another directory. Now we are going to open some NetCDF. First of all, you can click on the plus icon here to import a NetCDF, but you are limited to import NetCDF one by one, or you can just drag and drop your NetCDF from your directory to the plugin. Now you can see that your first NetCDF is here, so you have the complete name here and the path of this NetCDF. You have access to all the variables contained in your NetCDF, and here also you have access to several metadata with the resolution of the project and plenty of information regarding your project. Here it's a model project extracted from a physical model at a monthly temporal resolution, and we are going to display some variables of this project. If we select the salinity variable here, you have two options to display this variable to your QGIS project. So first of all, I can right click on it and select add layers, and here the one option of this plugin is to select directly a time frame of your NetCDF file, avoiding the complicated properties of QGIS. So here we can select directly one or several time frames, selecting with control. I select the first 3 time frames. I have only one depth, so I don't need to select a depth. And I can change the name of the group to import the layers on. Here I set the minimum and maximum value on the minimum and maximum value of all layers, and I keep this palette. You can click on add and close here, and you can see that on the background the 3 layers have been imported to your QGIS project. If you zoom on your map, then you can see that you have your several layers here. You can go back to the plugin, and here I am going to show you how to visualize several time frames in a kind of animation. So you can right click on your variable you want to display and select sequence layers. Here typically you can select all the time frames or several time frames using control or using the shift key on your keyboard and going to the bottom of the time frames. You can select all the time frames, select the name of the group and the minimum and maximum value of the layers, and select a time step to display each frame. Here we select a frequency of 2 seconds and we can click on start. If we go to our QGIS project on the background, you clearly see that there is an animation running, and each 2 seconds you can see the layer changing from a time frame to another. So it's really convenient to see quickly the evolution of one variable in QGIS using this NetCDF plugin. Then you can go back to the dialog box and stop the animation. Now you can close this window and go back to the plugin. Other option you have are to check or uncheck some layers on your QGIS project, or to remove some layers from your QGIS project. Here, if we activate all the layers, you can go back to your QGIS project. And for example, if you want to remove the layer corresponding to the 16th of October 2020 here. You can right click on it and remove it from list. Yes, and you will see that it will remove this layer. Now you can also uncheck some layers. For example, if I want to uncheck the first layer here of the sequence group, I can go to the sequence group, find the layer and right click on it and select uncheck in QGIS. And now you can see that this layer has been unchecked. So you can play with several layers like that and remove some layers, or you can also remove all the group. So if you select one layer in the group sequence and click on remove group, and yes, all the sequence group has been removed. So here are the basic options of this plugin. One last option is to save one layer as a TIFF. So if we go to the layer, select it, right click on it and select save as TIFF. Here you can select a directory, or if you have changed the output directory here in option at the beginning, it will be displayed here. And you can select the palette you want to use to extract this layer as TIFF. And now you just have to select save as TIFF, and your new layer as a TIFF format is saved and displayed on the QGIS project. Thank you for your attention. There is a part.
Okay. Thank you to our virtual Etienne that made the video. And so if there is any question raised to the QGIS we just saw, Muriel is here to answer. Actually, I do not see them.
Yes, in this short video, there is also other abilities of the plugin to modify several variables, to plot a vector or to align layers. So please feel free to ask your question.
Okay, I do see a question actually. It's where we can download, where can we download the NetCDF plugin? Is there any link? Actually, I don't know to whom.
That's me.
Okay.
I just posted the link so you can give it to our users.
Okay, thank you. For the question about where we can get the video tutorials, Fabrice just show you before, you have the Padlet with all the material of the training. So there you will find all the videos recorded and the exercises and the presentations. I do not see any other question coming. So maybe we go on. So I give the floor again to Fabrice to close the circle from the beginning.
Okay, thank you, Paola. So this is a short presentation about the Jupyter environment, and I will start to share my screen and show you the different link you can we share with you and you can find on the Padlet. So this is the Padlet, and if I click here on e-learning material, you will be directly moved to the e-learning material web page on our website, and directly with the material dedicated for this training for the America workshop. So you can see here in pink color the different e-learning material corresponding to the Jupyter Notebook and their tutorial videos. In blue, the training material on RStudio and a GIS, a QGIS tutorial video on river plumes and nutrient-rich areas around South America. And if you want to download the plugin, just go on Tool here and you make a search with GIS, and you will have access to all the tutorial video. And here you have the QGIS plugin, and you can you have all the documentation and the demonstration to install the plugin. Okay. Now I go back to the Padlet again. As I said at the beginning, you have until tomorrow 12 p.m. 12 p.m. to apply to register to have access to the Jupyter Hub. And once it's done, let me show, you will have access to this platform, so the Jupyter Hub platform. I already opened a window. Okay, this is it. So this is the Jupyter Lab platform, and you will access this folder with Training America. And in this folder, you will have access to all the different products and Jupyter Notebook dedicated to these products. So for example, if I click here, you can run the Jupyter Notebook, and it's very simple because the Jupyter platform is an online solution to have access to this Jupyter Notebook. It's very simple. You have different cells, and you have just to click the play button to launch the different cells, cell after cell. Okay, and you will have the results. But if you need to make some modification, or if you need to save the Jupyter Notebook, I encourage you to copy and paste the notebook on your own directory. So here, this is your home directory. If I open a terminal, just be sure about the path to access the Jupyter Notebook you want. So for example, I want again to run the Jupyter Notebook dedicated on the Wave products. So I just check the pathway. So share notebook, then Training America here, okay. And now this is number 3. So this is the path, and you have just to copy this path and just make a copy with a parameter recursive copy of all the directory, and you have just to copy this line, copy, paste, and just add a dot to be sure that this will be copied on your home directory. You just click OK, enter, and that's it. And now, if you go on your home directory, you will see appear your folder about the Wave model product. And here you can launch again the Jupyter Notebook, and you can make your modification, and the modifications will be saved. Okay, so it's very important if you want to test the Jupyter Notebook and if you want to save your work. Okay, last thing I want to show you about this. I go again on the website of Copernicus. Yes, Jupyter on the Padlet. You have this link here, Jupyter environment, and we explain you on this page the different solutions you have to run the Jupyter notebooks. Okay, there is online solutions and there is an offline solution. If you are advanced people, you can install directly on your computer Anaconda, which is an open source Python distribution platform, and you can directly download from the Jupyter Lab by clicking here, download all the Jupyter notebooks and the dependencies to run on your own computer on Anaconda. Okay. The other solution, online solution, is a Wikio platform, and you can have access to this Wikio platform. This is a platform the registration is free, and you will have access to a Jupyter Hub environment, especially for you. And the Jupyter Lab, I presented before, this Jupyter Lab. So again, you need to be registered to the Copernicus Marine Service. The registration is free, and be registered to the workshop and complete the type form here. The link is here. You have just to give us some information to be sure that you are already registered to the Copernicus Marine Service and the workshop. And I think that's it for me.
Okay, thank you, Fabrice. It's all for you, and I think it's all for for the whole day as well. I do not see any questions in the chat. So thank you all the panelists of this afternoon for the practical session. So to Javier, to Muriel, also to Etienne in the video. Thank you to Fabrice, of course.
Thanks to you.
Thank you. So you will receive an email, a thank you mail for today. And this email you will find again the link to the material, to the form to fill for the access to the Jupyter Hub, and also the login for tomorrow. Because I remind you that tomorrow we have the second part of this training. So again, at the same time for UTC, there will be the same format. So you will have other 4 presentation, general presentation on the products, modeling and in situ products, and then some other practical sessions, in particular for the Jupyter notebooks we just saw, and also for the Art Studio. So we are looking forward to see you again tomorrow, and have a nice day or evening, depending where you are, and see you tomorrow. Thank you.
See you tomorrow. Bye, everyone.
Bye.